Hey guys, welcome back to another video. So here we're going to do a complete walkthrough and breakthrough of the C1 Edexcel A-level paper. And this is back in January 2005. So this is quite a while back. Now, how about we just jump straight to the paper, okay? So let's go. Okay, scrolling down. Oh yeah, so calculus cannot be used in this exam. So as usual, only for C1 you cannot use any calculus. Okay, question 1. So here we need to write down the value of 16 to the power half. Okay, all we need to know is that the power of a half represents square rooting. So this is simply the square root of 16. And this should give us either positive or negative 4. And that's it really. Part B, find the value of 16 to the power of minus 3 over 2. So let's get some rules. If the power is negative, this means we need to take the reciprocal. So the answer is going to be 1 over 16 all to the power of 3 over 2. Now, to understand what these numbers are, the 3 part represents cubing and the 2 part here represents square rooting. So if you've got a fraction that's on the bottom half, it's going to be on the rooting, or in other words, the nth root. In this case, 3 over 2 now is going to be the square root of 16, which we know is 4 or plus minus 4, and then the cube of 4. So let's say the cube of 4. This means 4 times 4 times 4. And this should actually give us 4 times 4 is 16, and then 16 times 4 is 64. So the answer is going to be plus minus 1 over 64. And that's it. That should really be it. Now, let's move on to question 2. So given that y equals 5x cubed plus 7x plus 3, find the first derivative. Okay, easy stuff. So all we have to do is literally drop the power and then multiply it head on. So the first one, 5x cubed. Drop the power down, so it'll be 5 times 3, which is 15x, and then subtract the power by 1, 2. Next one, 7x. Since you can imagine this 7x to the power 1, drop the power down, so 7 times 1 is 7, and then x to the power 0 is nothing, so just 1. And that's it. And then differentiating a constant, well, that becomes 0. So that's your answer. Yeah, you used to get a lot of marks for these, you know. Now, the second derivative, this just means differentiate this again, so drop the power, you get 30x power 1 and 7 disappears. Now for this one, find the integral of this expression here. So what we need to do first is write this in its correct x to the power form. So 1 seems to be okay. Now 3 root x. Root x, if you remember, was x power half. So this is 3x to the power of 1 over 2. Now you got 1 over x squared. So if any numbers on the bottom half of the fraction, you need to just bring it on the top line and stick a negative sign. So it'd be x to the power of negative 2. And that's it. Now we just have to integrate this entire expression. So what does it give us? So integrating 1 will just give us x. Integrating this value, 3x to the power half. Well, all you have to do firstly is raise the power by 1. So it'll be 3x power of 3 over 2 all over 3 over 2. And finally, add 1 to this power, so it'll be x to the power of minus 2 add 1 is minus 1 over itself, negative 1. And finally, add plus c. Easy, guys. Now, all we have to do is just tidy this up. So 3 over 3 over 2, well, you could just think of it like this. Let me just change the color. So it's just 3 divided by 3 over 2. That's just the same as 3 times 2 over 3. You just literally flip this upside down. So 3 times 2 over 3, well, these two cancel out. So you're left with just 2. So this entire expression becomes x plus 2 to the power 2 times x to the power 3 over 2. Minus minus becomes a positive x to the power minus 1 plus c. And that's it. Now let's move on to question 3. So given that the equation kx squared plus 12x plus k equals 0, where k is a positive constant and has equal roots, so it's right here, find the value of k. So equal roots means that you're firstly working with the discriminant. So you're just caring about the square root part in a quadratic formula. In other words, you're looking at b squared minus 4ac. And since it has equal roots, that means you're going to get the same solution. So it must equal 0. Now let's label everything. So here we've got a equals k, b equals 12, and c equals k. Now using the formula, b squared, so 12 squared equals 144 minus 4 times k, so minus 4k squared equals 0. And solving this directly, so 144 equals 4k squared. So we can say 4k squared equals 144. Dividing it by 4. So halving it, so this is just, remember, this is all mental math. So halving it is 72. Another half will be 36. And finally the solution is k equals plus minus 6 once you square root it. And since k is positive, then the only solution is going to be k equals 6. Okay, question 4. Now we have to solve the simultaneous equations. Okay, so this is easily one of my favorite equations, you know, favorite things to do. All you have to simply do is pick something, make the subject, and plug into the other equation and solve. So what I would always do is firstly look at this and see what's easy to substitute. Well, I ain't going to put x in here because then I'm going to be squaring the term. So I'm going to replace the expression for y into here, 2y. So let's have a go at it. So rearranging the first equation, making y the subject, we should get y equals 2 minus x. And then doubling this, we can get 2y equals 4 minus 2x. Now replacing 2y with this entire expression, we should now have x squared plus 4 minus 2x equals 12. Now, putting everything to one side by subtracting 12, we're going to get x squared minus 2x. So 4 take away 12 will be minus 8 equals 0. And voila, now all we do is just factorize. So put in a double bracket, put an x on both of them, and now we just need to think two numbers that gives us 8, because it has a product 8 and a difference of 2. Well, I can easily think of it. It's going to be 4 and 2, because 4 times 2 is 8, minus 4 add 2 is minus 2x. So this will be minus 2, minus 4n plus 2. And finally, this means that we're going to have now x equals 4 and x equals negative 2 as solutions. If you're not sure why that is, because it says here that x minus 4 times x plus 2 is 0, meaning one of these two are both 0, or one or both are 0. So we can say x minus 4 equals 0, gives us x plus 4, x plus 2 equals 0, so we get x equals negative 2. Now, don't forget, once you solve this one, you're not done yet. You have to find y. So, and thankfully, well, we have the expression here, y equals 2 minus x. So we can say when x is 4, y equals 2 minus 4, which is negative 2. And when x equals minus 2, we're going to have 2 minus minus 2, so 2 plus 2, which is y equals 4. So you can see they're actually inverted. And that's it, guys. That's number 4 done. So how about we move on to question 5. So here we go. The half term of an arithmetic series is AR minus 5. So just to let you know, the general formulas are always this. So we're given the nth term, the nth position, which is always a plus d times n minus 1. And also the sum of n terms, which is n over 2 times 2a plus d times n minus 1. So it kind of looks like the first one, but it's a summation version up to the n, to the sum of the first n terms. Now, write down the first 3 terms of this series. Okay, so the first 3 terms is quite easy. We just have to replace r with 1, 2, and 3. So when r is 1, we're given 2 times 1 is 2, 2 minus 5 is 3. When r is 2, the second term, we're given 2 times 2 is 4, 4 minus 5 is negative 1. And you can kind of guess the next one. When r is 3, 3 times 2 is 6, minus 5 is 1. Okay, that's it. So the first 3 terms is minus 3, minus 1, and positive 1. State the value of the common difference. Well, the common differences is going up in positive 2's. Now show that the sum of this equation can be written as this. So this means that the sum of the first n terms. So in other words, using the original formula. So what we need here is a value for a and a value for d. So we can say that the sum of the n terms when a equals the first term, which is negative 3, and d equals 2, we can say that the sum using the formula, so n over 2 times 2 times a, so 2 times minus 3 is minus 6, plus d, which is 2 times n minus 1. Now, let's expand this and simplify. So we should get the following. So expanding inside, we should get, okay, we got n over 2, so we got minus 6. So expanding this part, we should get 2n minus 2. So minus 6 minus 2 is minus 8, so we have 2n minus 8. Okay, so let's expand this part. So we got n over 2 times 2n. So we're going to have 2n squared over 2 minus 8n over 2. And then tidying this up, we should get n squared, so these cancel out, minus 8n over 2, cancel down by 2, we get 4n. And finally, factorizing to get the similar expression, we should get n times n minus 4. Easy, very easy. So far the first 5 questions have been pretty relaxing. So if you got everything so far, you know, give yourself a pat on the back. And let's move on. Okay, question 6. So it looks like we're given a curve with some points given. So figure 1 shows a sketch of the curve with equation y equals fx, and we see that the curve crosses the x-axis at the points 2, 0, and 4, 0, which are over here. And the minimum point is given by this point here. So very simple. In separate diagrams, sketch the curve with equation, firstly y equals negative fx, and then y equals f in a bracket 2x. So give all the information you need to give. So, alright, so let's have a go anyway. And the coordinates, okay, that's fine. So negative fx, what does that mean? So this means if you've got a negative coefficient, this means all the y coordinates are now flipped. Of course, nothing happens to the x because the x remains the same. So this means if you look at the shape here, you got coordinates as 2, 0, and 4, 0. That means because these coordinates are 0, the y's are 0, they don't really change, they're the same. But this one's negative 2, so it's going to be positive 2. So this 3 minus 2 will come up here as 3 positive 2. And this means this shape here will come from the bottom. So let's sketch it carefully on a simple sketch on this side. So if it comes from the bottom, it's going to cut through 2. Here, a maximum point over here, which is 3, 2. Go back down to 4 and then float away. And that's it. This is literally the graph needed. For the second one, this means if you got 2x, all this really means that you half the x value. So notice you got 2 and 4, you just half these values. So all you're doing is squeezing the graph. And 3 becomes, well, 1.5. So it's going to be the same shape, except now the values have been squashed. So this is going to be 1 and 2. The lowest point is going to be 1.5 and negative 2. That's it. Very easy. So how about we move on? Okay guys, number 7. So it looks like we're given a curve C with this equation where we have a quadratic term here and a fractional term. So first things first, usually with these kind of equations, I always like to break it down into power form because it can be hard to work with this if you're differentiating, like in part A. Also, we know that the point P on C has x coordinate 1. This information here, by the way, x doesn't equal 0, is just saying, it's just implying that the domain cannot be 0, so we can't divide by 0. That's all it is, just technical stuff. Now, given that the x coordinate is 1, let's just plug in and find the coordinates of P, because it's good to find the whole coordinates right now. So when x is 1, what do we have? We've got 4 times 1 squared, which is 4. 5 minus 1 over 1. So 5 minus 1 is 4. Over 1 is still 4. So 4 plus 4 is just 8. So the coordinate is 1, 8. Okay, now we start the questions. So A, show that the value of dy of dx at point P, so at point P when x is 1, sorry, is actually 3. Easy stuff. Okay, so let's do that. So let's differentiate this equation. So we should get dy over dx. 4x squared becomes 8x, so drop the power 2, 4 times 2 is 8. Now this term here, well, let's rewrite it first. So the y equation should be 4x squared plus, now let's partition this. So we can split this as 5 over x minus x over x. So 5 over x is the same as 5 times x to the negative 1. So remember, you can bring x to the top line, take a negative 1, minus x over x, they cancel out, and you just get 1. So easy to differentiate. So differentiate 5x negative 1, drop the negative 1, we get negative 5x, and then subtract the power by 1, you get negative 2. And then differentiate a constant, well, that vanishes. So now all we do is plug the value of the point P, which is x equals 1, into this equation. So we should get now dy over dx is, so 8 times 1 is 8 minus, so this is 5x and negative 2, or this is the same as 5 over x squared. When x is 1, you get 5 over 1 squared, so 5 over 1 is just 5. And therefore 8 minus 5 is 3. Voila, that's it, guys. You got your first point, and you get 5 marks for that. That's quite easy in my opinion. Now part B, find an equation of the tangent to C at point P. So equation of tangent is just simply y equals mx plus c. All you need is the gradient at point P. So P we know is at 1a. So all you really do, you know your gradient m. So dy dx is also the equation of a gradient, and we know that the gradient at point x equals 1 at point P gave us a gradient of, well, 3, because dy dx is 3. So we have everything. We got x is 1. We know that y is 8. Just plug in and find c, and then voila, rewrite it without m and c. So plug in your corners. So you got y equals 8 equals m is 3, x is 1 plus c. And that's it. This is easy maths. 3 times 1 is 3. 8 minus 3 is 5. So c equals 5. That means the equation of the tangent is y equals, replace m with 3, 3x plus, and c, which is 5. Easy stuff. Finally, I should catch my breath. Finally, this tangent meets the x-axis at the point k0. Okay, oh wow, this is easy. Find the value of k. So it says this equation here meets the x-axis at this point. It even gives you points. So plug in these points for here, and then you should get the value. So we know k is x and y is 0. So we're going to have 0 equals 3 times k plus 5. Just solve this. Subtract 5 and divide by 3. So k must equal minus 5 over 3. Easy. You know when maths is this easy, honestly, I just love it. Unfortunately, the 2018-19 papers which are gonna come may not be like this, but hey, this is still good practice before you get to the recent years. Alright, let's move on. Okay, here we go. Question 8 now. So it looks like we're given a shape. We've got point A, point D, point C, and point B. So we've got a triangle. Looks like this is a straight line here, I think. So we've got points A, B, and C form the vertices of a triangle as shown in figure 2. And we know that point D here is the midpoint AC. So this is the midpoint. Find the value of P and Q. Alright, easy stuff. So all you need to know is the midpoint equation. So we should know that the midpoint D equals the average between these 2 points. So obviously you can't write like this, but this is just an idea. That means based on the value of x, we can work out the x coordinate C, and based on the value of y for the midpoint in A, we can find value Q. So we can generally say that the general equation will be this. So we can say that the midpoint A was found by adding 1 and P and dividing by 2. And the midpoint for 1 when we got 2 can be found by saying 2 equals the sum of 7 and Q over 2. Now you just solve this. So this is literally the midpoint. That's how you get the midpoint. So now working this out, 8 times 2 is 16, minus 1 you get 15. So that's your P. 2 times 2 is 4. Take away 7 is negative 3. So Q equals negative 3. And it makes sense because it seems to fall on the negative axis. So we can say therefore C is going to be 15 and minus 3. Okay, so the line L which passes through D and is perpendicular to AC intersects AB at E. Okay, so what this means is that you got a line L passing through D, which is this point here, and it's perpendicular to AC. So this line is AC. So we're looking at a perpendicular line, a very straight one, not my dot version, which cuts like this. So it has to be a perfect 90 degrees. And let's call this point E because it cuts AB. Find an equation for L in this form. Okay, easy stuff. So all we need to do is find the gradient at point D, and then voila, we can find out what this value is. So first things first, we need an equation that is y equals mx plus c. Now, what can we say? So do we know the gradient of this line? Well, yeah, we could. We could literally just find a gradient from A to C because we need 2 points. The difference in gradient can be found the change in y and x. And then we flip it to get the gradient at D. So firstly, let's find the gradient of this line here, of the line AC. So we can say the gradient is the change in y over the change in x. So change in y, so 7 take away minus 3 will give us 7 minus 3, which is 10. 1 take away 15 is negative 14. So that's going to be 5 over minus 7. That means when you find the perpendicular gradient here of the line, let's call this line L, because that's what it said, isn't it? The gradient here is going to be, let me see, reciprocal. This one will be the positive negative reciprocal, so it'll be 7 over 5. And you're given these points, and that's it. Now we just plug everything we need. We got 8, 2, and we got 7 over 5. So let me put it here. So we got y equals mx plus c. Popping in the gradient and these two coordinates, 8 and 2. We got 2 equals 7 over 5 times 8 plus c. And that's it. Now we just work this out. So multiply everything by 5 to get rid of the fraction. So we're going to get 10 equals, well, 7 times 8 should give us 56 plus 5c. Wait, I should be working out c first, isn't it? Okay, so let's work this out. Subtract 56, we're going to get, I need more space. 10 minus 56 is minus 46 equals 5c, and then therefore c equals minus 46 over 5. Yep, looks good to me. So that means, and yeah, because it has to hit this negative axis. So therefore, our equation of a tangent is y equals mx, so 7 over 5x minus 46 over 5. Timesing everything by 5 to get this form. So we should get 5y equals 7x minus 46. Now rewriting to ax plus by plus c, we should therefore get, so subtracting 5y, we should get 7x minus 5y minus 46. Yeah, and this would equal 0. Not bad, guys, not bad. And finally, find the x coordinate of E. Well, it's on this line AB, isn't it? So to find it, because it intersects this line, let's find this equation for this line. So this line is going to cut at 7. So you can see clearly this line here is just y equals 7. So we can plug in the value of 7 into this equation. So plugging in 7, what do we get? We get 7x minus 5 times 7, which is 35, minus 46 equals 0. So what does 7x equal? 35 take away minus 35 minus 46. So put this in the calculator. No, put this in. So well, solve this as you can, and you should get negative 81, or other side positive 81, and therefore x is 81 over 7. Good stuff. Now I want to tie this up, and we can move on to question 9. Okay, question 9, guys. So the gradient of the curve C is given by this differential equation. So we got dy over dx equals 3x minus 1 all squared. Okay, the first thing you want to do is you want to expand this bracket, because it's always easier to have them in the standard way. So expanding this double bracket, which is also written as 3x minus 1 times 3x minus 1, we should get exactly 9x squared. 3x times 1 is minus 3x, and another minus 3x, so you got minus 6x. Minus 1 will give you a positive 1. So this is the full expansion. Okay, now it says that the point P with x coordinate 1 and y coordinate 4 lies on C, on this curve. So the actual equation. Find an equation of the normal to C at P. So this is just the gradient equation, right? So for the standard gradient, we want to find the normal at the point P. So we can say at the point P, when x equals 1, that's the point P. Replacing 1 into this gradient equation, we can say that dy over dx will give you the normal gradient at point 1. So you got 9 times 1 minus 6 plus 1. Minus 6 plus 1. This should give us a 3. So give us 2. So the standard gradient is 2. That means the perpendicular gradient of the normal. So gradient of the normal, so let's call this normal equation, or perpendicular equation, is going to be the reciprocal and a negative. So will be half times the negative, so minus half. Now, the standard equation is always y equals mx plus c, where m in this case is the perpendicular gradient. So m is minus half, and we plug in the coordinates of c, p, which is 1, 4. So we're going to have 4 equals m, which is minus half, times by 1, which is itself, plus c. And therefore, c is going to equal 4 plus half. which is 4 1/2 or 9/2. Hence the final answer is going to be, so let me change color of the pen. It's going to be y equals m, which is, what's m again? Minus half x plus 9/2. And that's it. So this is our actual equation. Right, so find an equation for the curve C in the form y equals fx. Again, easy. We're given our gradient equation. To get the original, we just have to integrate. So integrating the dy of dx equation, we should get y equals, so 9x squared becomes 9x cubed over 3, which is 3x cubed, minus, integrate 6x, you get 6x squared over 2. 6/2 is 3, so you get 3, and then you got x squared. Plus 1 just becomes a plus 1x or x, and then of course plus c, the constant of integration. Now, to find the actual value of c, well, substitute the value of, I don't know, p or something, anything that has x and y, so to find c. Plug in this coordinate into here. So what should we get? So we're going y equals 4, we're going to get, so I'm going to change the color to red. Let me do it down here. So it's going to be 4 equals, so x is what, 1. So 3 times 1 cubed is 3, minus 3 times 1 squared is 3, plus 1 plus c. 3 minus 3 cancels out. So we got 4 take away 1 is c. So therefore c here is just 3. That's it. Easy stuff. Finally, using dy of dx equals the equation given, show that there is no point on C at which the tangent is parallel to this line. Okay, let's have a look. So blah blah. So this line is going to be y equals minus 2x plus 1. So we know that the gradient is the equation of tangent is parallel if the gradient is -2. So we need to show if there's a gradient of -2 at all. And to do it, we need to set dy of dx to -2. So let dy dx equals -2 and equate it to this equation, 3x minus 1 squared. Okay, so yes, obviously we can't solve this. The reason why we can't solve it is because if we cannot square root a negative, so hence cannot be solved. Because this cannot be solved, we can simply say that there cannot be no gradient, so it doesn't intersect at any point. We can also add the fact that the only way to solve this equation if the gradient was 0 or bigger. So hence, the only way we can do this if we had, say, 0 or greater equal 3x minus 1 squared. So if this was 0, 1 or greater, then it can be solved. Otherwise, that's it. Done. Okay, so let's move on. So otherwise, this can never be solved. Okay, question 10, final one. So given that fx equals x squared minus 6x plus 18 for all positive values at x, express fx in this form. In other words, complete the square. So in order to complete square, all you do is take the first two terms and then half the coefficient of 6 to get 3, and then wrap it in a nice bracket. So we should get something like x minus 3 all squared. Let me just bring the page up a bit because we've got so much space, and then copy the rest, plus 18, and all we do is subtract the square of 3, so minus 3 squared, and then you're done. So the final answer is going to be x minus 3 squared, and then 18 take away 3 squared, which is 9. 18 take away 9 is positive 9, and that's it. That's your answer. A is 3 and B is 9. I'll just write here as well. So always keep your answers in full, yeah? Okay, final part. Okay, next part. So the curve C of equation y equals fx, where x is positive, meets the y-axis at P and has a minimum point at Q. So firstly, the minimum point represents the turning points. So this curve here, suppose it looks a bit like this. This would be the turning point, TP. And usually we can differentiate to find turning point, or we can use the coordinates of this equation, because this gives you the turning point at A and B. So given that A is 3 and B is 9. So these are the coordinates of the turning point. So the minimum point at Q is clearly 3, 9. And when it meets the y-axis at P, so the y-axis means that it hits at a value of x equals 0. So you plug in 0 into the y equation. 0 squared minus 6 times 0 is 0 plus 18. So the highest point is 18. So that is the y-axis, and that is this. Sketch the graph of C showing the coordinates of P and Q. All right, easy stuff. So we have a quadratic equation. So this is quadratic. So we can just do a bit like this. So minimum point is this. And it's all positive, it seems. So it's minimum point somewhere here. So we just flick it upwards. So it's meant to be a, whoa, oh my god. So it has to be a smooth U shape. So something like this, where this one is the minimum point, this is Q, and this is 0, 18, which is P. Okay, the line y equals 41 meets C at the point R. So line 41 cuts there. Find the x coordinate of R, giving your answer in this form. So clearly the line cuts this curve. And we know the curve equation, so we connect y equals 41 to here. So let me write at the bottom here. So we've got the original curve equation, which is, you can call it y, x squared minus 6x plus 18. Plus 18, and it cuts at y equals, what was it, 41? 41. So just find the coordinates or the x value. So that's it. Now we can just solve this simultaneously. So this whole equation equals 41. So subtract 41 across, you've got x squared minus 6x, so 18 take away 41. So just do some calculation and you should get minus 23. And that's it. Now we just solve this equation. So using the quadratic formula if you like, or completing a square, up to you. I mean, I guess completing square would have made more sense because they've already done it for you. So you could just equal this to 41, subtract it and get, yep, that would have worked fine. I'm going to use the quadratic formula because we already did this well. So we can say x equals minus b plus minus the square root of b squared minus 4ac all over 2a. And this equals to minus b is minus 6, so it would be 6 squared. So it would just be positive 6 plus minus b squared, which is 36. Yeah, as I was saying, so 4ac, so it would be 4 times 1 times minus 23. So let me put the values a, b, c here because I didn't do that. So a was 1, b was negative 6, and c was negative 23. So we go 4 times negative 23. So 46, 92. Yep, so 92. So it'll be, and because you got minus minus, it'll be positive 92. Okay, cool. All over 2 times a, which is 1, so 2. Now let's sort this third over here. So you got 36 plus 92. This should give us, you got 8, 120, so you got 128. Now the key idea here is to try and break this apart. So I always do the factor tree method. So let's just work out this value here before we get back to sorting this problem. So root 128, it can be broken down into prime numbers. So let's do 2's here. So 2, so half of this will give you 64. So root 2 to root 64. Oh, I guess we're done. Because we should know that the square root of 64 is just 8. So then the final answer is going to be, for root 128, 8 root 2. Oh my god, that is that is so convenient. Okay, great. So it's 8 root 2. So we can definitely say now that this entire expression over here equals to 6 plus minus 8 root 2. 8 root 2 all over 2. And now just dividing your whole numbers. So 6 over 2 is 3. Plus minus 8 over 2 is 4. 4 root 2. And the last thing I need to note is that the answer, was it 1? Give your answer in the form p plus q. So the final answer should be 3 plus 4 root 2. That's it.